This is your solutions video to answering scenario questions on slide 9. Okay, so remember, if you've checked the slide previous to this, it'll give you a walkthrough of how you can now plug in an X value or a Y value to solve for the unknown that you're looking for in that question, okay? So number 1, an accountant charges $15 per hour for a consultation plus $50 for the meeting. If you remember from before, we had come up with the equation that we were going to use for that, which was y equals 15x plus 50, right? 15 was our per hour, it was our slope, and that $50 was our constant, it was that y-intercept, okay? So question A is asking, how much would they make for a 3-hour consultation? So before we even actually get into those questions, I just want to let you know this is a really good tip to kind of keep track of what you're doing in the equation. You need to identify what the y is and what the x is. So in this case, y represents that total cost. And anytime I use x, x is going to represent the hours that the consultation lasts, okay? This is just going to help me keep track of things as I go through it. So question A was asking us how much it would take for a 3-hour consultation. So I know if x was the hours, x is going to be the thing that will be equal to 3, and what I'm going to be looking for is that y. I don't know the y variable yet, okay? So using that formula, y equals 15x plus 50, let's go ahead and substitute in that x value of 3. Remember, we still don't know y, so y stays the same, okay? 15 times 3 will give us 45, plus the 50, y will be equal to 95. And that's telling us the total cost, right? So therefore, it will cost $95 for 3 hours. Okay? B, how many hours did they work if they made $117.50? So for B, we know the total cost. We know that it was $117.50. We don't know how many hours it is. That's what we're going to be trying to figure out. Okay? So again, I'm going to go ahead and substitute in, I'll write out the equation first, and then I'll substitute in the values that I know. So I know y is 117.50. I don't know the x, so everything else there gets kind of repeated, okay? Now, remembering back to what we learned in algebra, we want to isolate that variable. We use the balance method, we bring everything else away from it, okay? So if I want to get rid of that plus 50, I do the inverse operation, which is subtract 50, okay? And then 117 subtract 50 will be $67.50. And all that I have left over then is that 15x, because these have now canceled each other out. Okay, there's a 15 attached to that x, that coefficient I want to get rid of. And right now it's multiplication, so I'm going to do the inverse operation, which is division. What I do to the one side, I have to do to the other. That will now cancel that out. 67.50 divided by 15 is 4.5, and I'm left with 4.5 equals x. Okay, so if I look at this, my therefore statement will be they'll work 4.5 hours, because we're talking about x, which is hours, for the $117.50. Okay? I'm just going to put a line here so we don't get confused. There we go. And one there. All right, number 2. A taxi driver charges a base rate of $4.60 and then 30 cents for every kilometer. So this was the equation we came up with from that previous slide. And just like we did before, I'm going to identify what each part represents. So we're talking about a base rate of money, and then we're talking about a distance, right? So that y, again, in this case, will equal total cost, and x is not going to equal hours, it's actually going to equal the kilometers that taxi cab drives. Okay, so we're identifying what those variables are in our question. Question A, how much would you pay to take the taxi 7 kilometers in distance? So for A, we know our x is going to be equal to 7. We don't know what the y is, so that's what we're going to be substituting, that's what we're going to be solving for, excuse me. So here's the equation. Let's sub in our x value that we know, which is 7. And there's our constant. Okay, so 30 cents times 7 will be $2.10 plus the 460. Y is going to equal $6.70. So therefore, it will cost $6.70 for 7 kilometers. Okay, and B, how far would you drive for a charge of $10.60? So in this case, we know that total charge, it's $10.60. We need to know what the kilometers are. That's what we're solving for. So y equals, I'll start with the formula again, the equation. I'm going to sub in the $10.60 for y. We don't know x. And then let's see if we can use that balance method to figure it out. Okay, so right now it's plus 460. I want to get rid of that, but what I do to one side, I have to do to the other. That cancels that out. $10.60 minus $4.60 will give us a total of 6. And then I'm left with 30 cents per that kilometer. Let's figure out what just that kilometer will be. So divide by the 0.30 to cancel it out. What I do to one side, I have to do to the other. 6 divided by 0.3 gives us 20 equals x. So therefore, for $10.60, he can drive 20 kilometers. Okay? So those are your answers for that one. 3, a balloon store charges $10 for the helium plus a 10-cent filling charge for every balloon. How many balloons were filled if the charge was $15.50? So here's our equation that we came up with from before, y equals 0.10x plus 10, where y will equal that total cost, and x will equal the number of balloons, right? Because it's a 10-cent filling charge for every balloon. So number of balloons. All right. So we know the total charge right now was $15.50. So we know y. We are looking for x. So here's our equation. Let's plug in what we know. All right. So back to our balance method. We want to move the addition, get that gone by using a negative. What we do to the one side, we have to do to the other. 1550 subtract 10 will leave us with 550. And then we still have that 10 cents attached to the x. We get rid of that multiplication by doing the division. What we do to one side, we have to do to the other. $5.50 divided by 10 cents will give us 55 equals x. And remember, x was that number of balloons. So therefore, they can fill 55 balloons for that $15.50. Okay, and then our last question. The young child has $25 in his piggy bank. Each week he takes out $2 to spend on candy. How much would he have in his piggy bank after 6 weeks, and how long before it would be empty? So looking again at this, right? Y in this case is the amount in his piggy bank. And then X is going to be the number of weeks that have passed, okay, as he loses the money from it or as he spends the money from it. All right, so for A, we know the X value, or the number of weeks that we're looking for, is 6. We want to know how much will be left then in the piggy bank. So Y equals, there's our equation. Let's plug in the X value that we know. Y will be left with $13, okay? So, therefore, after 6 weeks, he'll have $13 left in his piggy bank. Okay? And B, how long would it take for his piggy bank to be empty? Okay? So using that kind of information, we know the amount in piggy bank, if it is empty, will be equal to 0. We need to know how many weeks it will take for that. So here's our equation. Let's make y equal to 0, and then we'll figure out what x will be. Okay, we'll move that 25 to the other side by doing the opposite or the inverse operation. 0 subtract 25 will be negative 25. We're left with the 2x. Let's get rid of that negative 2 coefficient. Negative 2 cancels it out. Divide by negative 2. And negative 25 divided by negative 22 will be 12.5. Remember, a negative divided by a negative will give you a positive. Okay, so for this, we could say how long would it take for his piggy bank to be empty? It would technically take 12.5 weeks. We kind of know that we don't represent things in the half week, so we could look at this. You can say, and you can round this up, it would take 12.5 weeks. I'm also okay if you rounded that up, or 13 weeks, right? Because we assume that they're always using sort of the same day. Okay, so you've created the equations. Now you're answering and analyzing different parts of that equation so that you can answer questions about it, trying to solve for that x and the y variables. So hopefully you understood this. Hope it was good.